In this example, we're going to use the software RStudio to solve an exponential problem. Computer response time is a typical application of gamma and exponential distributions. Suppose a study finds that a particular computer system has a response time that has an exponential distribution with a mean of 3 seconds. We're going to find the chance the response time is quicker than 1 second. We're going to find that what the chance is the response time will be longer than 4 seconds. And given a response time has already taken 6 seconds, what is the chance it will take longer than 10 seconds? Okay, so first off, let's go ahead and define what lambda is. Recall that the expectation of a exponential random variable is 1 over lambda. In this example, the expectation is equal to 3. So that means that lambda is equal to 1 over 3, or in other words, lambda is always going to be 1 over the expectation. So let's go ahead and define lambda. That's our parameter. And let's go ahead and define the average and standard deviation, because I first want to draw the exponential distribution just to get an idea of what it looks like. And so if we define the average and standard deviation and use this code to plot the distribution, we can see what the exponential distribution looks like for a lambda of 1/3 or an expectation of 3. And it looks like this. So now if we want to find the likelihood that our random variable is less than 1, then we can use this code p-exp. So this is always going to give me the probability that falls below the value that I'm defining. And I've put in my lambda, so that's either 1 over 3. I could even put 1 over 3 in here, but I've already defined lambda, so I'm just going to write it as lambda. I'm going to run this section, and I get that the probability is 0.2834687. So the likelihood that x is less than 1 or quicker than 1 second is equal to 0.2834687. So now if we want to look at what this looks like on the graph, I can define x equal to 1, and then I can use this code here to color in or shade in the area that falls below 1. So in this example, that is the quicker response times that are less than 1. And I can see that that's all shaded in here, and that is about 0.2, well, let's look at what that was again, 0.2834687. All right, so this is a nice visual that we can get for the exponential distribution. Now let's suppose I want to know the likelihood that the response time is longer than 4 seconds. I can then still use this p-exp command, so I can use the cumulative density function and just plug in my 4 and lambda, but this time I want the area that falls above the 4 value. So I need to subtract that from 1. So I'm going to go ahead and run this line, and I get that the area that is above 4 is 0.263835971. So that is right about here. And let's go ahead and change this value here. X now is equal to 4. And if I run this, I actually have to first rerun the plot. So I'm going to run the plot again. And if I rerun this part, I can then look at this gray shaded area is the area that is above 4 in my exponential distribution. And so that is the value of 0.2635971. All right, so for this last part, if we go back to the original example, it says given a response time has already taken 6 seconds, what is the chance it will take longer than 10 seconds? And so there's 2 ways that we can do this problem. We can consider the conditional probability, or we can do it using the fact that we know that the exponential distribution has the memoryless property. So back in R, if we wanted to just use the definition of conditional, then we could use these commands to find the conditional probability. That is the probability that x is greater than 10 seconds given it is greater than 6 seconds. And so this is then the probability that it's greater than 10 seconds. So this is going to be our numerator. And then our denominator will be that it's greater than 6 seconds. And if we run this all together, we will get then the probability that the response time will be longer than 10 seconds given that it's already been 6 seconds. And this is 0.2635971. However, if we use the memoryless property, then we can see that the probability of x being greater than 10 is the same thing that of probability of x being greater than 6 plus 4. Correct? Where 6 was the original given. And so now by this property, we know that this is the same, this value up here is actually exactly the same as the probability of x being greater than 4. And we actually already calculated that, and we know that to be 0.2635971. And that is the same probability as over here. All right, so hopefully this video helped you understand how you can use the memoryless property for an exponential distribution and RStudio.